Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hello again. Nice to see you. Today, we're going to learn how to name ionic and molecular compounds. Well, let's start. Let's go to my screen, and we can see our wonderful periodic table. And again, it's color-coded. It's color-coded with blue are metals, red is nonmetals, green are metalloids. So we need to remember our metals will form cations, nonmetals will form anions, and we also have polyatomic ions that we have to memorize and learn how to name. In a previous video, we learned about how to put together a formula for ionic compounds. So I'm not going to review that. You can go back and look at that video. Today we will just learn how to name it. So number one thing. This looks like a very big, scary chart. Don't worry. Everything is in one page, and I will walk you through it. Are you ready? So number one, the very first type of question you're going to ask yourself when you are faced with naming a compound is what types of atoms is the compound made up of? Let's go. Let's say you have a metal and a non-metal. Right here you have a metal and a non-metal. So let's go down this arrow. If you have a metal and a non-metal, you have an ionic compound. It's also they form salts. Ionic compound made out of two parts. They have your metal and your non-metal. Let's learn how to name metals. So, metals would like to lose electrons to form cations. Now, what are the names? How do you name cations? Well, most cations, it's the same as the neutral metal. So, for example, when sodium loses one electron and it becomes sodium cation, the name still stays the same. So sodium is sodium. Calcium, when calcium loses 2 electrons and becomes calcium plus 2 cation, well, the name doesn't change. Calcium and calcium. You do have to keep in mind you have one polyatomic cation. That is your ammonium. That's the one you should know. And there is also some transition metals which can lose 2, 1, 3 electrons. So they will have, we call it multiple oxidation states, and you need to memorize that. It is very important for you to know. So we can have copper. Copper can be +1 or +2 cation. Iron can be +2, +3. Cobalt +2, +3. Chromium +2, +3. Nickel +2, +3. There's a pattern here, isn't it? We will go over that another time. But we have mercury. Mercury is a little bit different. This is mercury 1+, because you have 2 mercuries and they will be a total of +2 charge. But that will be mercury 1+, mercury 2+, and then we have tin and lead can both be 2+ or 4+. For these, when you have a transition metals, you're going to use Roman numerals. Roman numeral is the charge. It is not the number of how many cations you have. Okay, let's go to the non-metal part. Non-metals like to gain electrons. They become anions. So if you have a single atom anion, you're going to drop the ending and you're going to add "ide." For example, chlorine becomes chloride. Sulfur becomes sulfide when it gains 2 electrons. There are polyatomic anions, and you have to memorize them. There is a system to it, though. So there is a systematic memorization. Let's go through this a little bit. So when nitrogen gains 3 electrons, nitrogen becomes nitride. And then you have nitrite and nitrate. So NO2 minus nitrite, NO3 minus nitrate. The one with more oxygen is 8. nitrate. The one with less oxygen is ite. Now, do not say, oh, everything with 3 oxygens is 8. No, no, no. The one with more oxygen is 8. So let's go to the next example. When sulfur gains 2 electrons, it is sulfide. But then we have 2 polyatomic anions with sulfur in it. One of them is SO3 2-, that's sulfite. And then we have SO4 2-, that's sulfate. So the one with more oxygen is sulfate, is 8 at the end. And you just go through that chart. So go through this whole chart and you should memorize these common polyatomic ions. And the only one with plus positive charge is the ammonium. So here is how you're going to name the ionic compounds. And we will go through examples, but that's the plan. Now, if you have non-metal plus another non-metal, you're going to have molecular compounds. They are held together by covalent bonds. And with molecular compounds, you are going to use the prefix system. Here is the prefix system. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, like Pentagon in Washington, D.C., right? 6 is hexa, hexagon. Think of your geometry shapes. 7 is hepta. 8, octa, octagon, stop sign, octopus. Yes, has 8 arms. 9 is nona. 10, deca, like decades. Do you like decade date in school? So here is an example. When we have CO2, we call it carbon dioxide. So we drop the ending and we add "ide" and we put the prefix. So there's 2 oxygens, so we call dioxide. Notice the first element, even though it's 1 carbon, if it starts with 1, we do not say monocarbon dioxide. We just say carbon dioxide. Here is N2O4. Well, how many nitrogens? 2. What's the prefix for 2? Di. So dinitrogen. And then it's 4 tetraoxide. The second element is ide at the end. So this is the plan. That's how all of the naming works. Let's do a little bit of practice. So first, I separated them. First, we're going to practice how to name ionic compounds. And I think when you first are learning this, you should make a chart like this for yourself. Separate your cation, separate your anion. Make a formula, like we did in our previous video, and then you write the name. So if we have one potassium with a +1 charge, and oxygen with a -2 charge, the formula for this has to be 2 potassiums, K2O. And what's the name? Well, this is our ionic compound. Remember, it's single cation, so it will be the same name. So it will be potassium. And if it's a single element as your anion, we drop the ending and add ide. So oxygen becomes oxide. Okay, let's go to the next example. Let's look what we have. We have calcium and sulfur. You should look at your periodic table and realize, okay, my cation is calcium. It will be a 2+. It's my alkaline earth metal. And sulfur will be, it's right under oxygen, 2-. So the formula is 1 calcium per 1 sulfur. And what is the name? Well, again, cations, single cation, same as neutral elements, so calcium. And then single element anion, you drop the ending at ide. Sulfide. Okay, let's crank it up a notch. Let's go to our polyatomic ions. So we have sodium and hydroxide. Sodium will be +1 charge, alkali metal, +1. Hydroxide is my polyatomic anion with this is my charge for it. And now we have to bring it together. Oh, it's a 1-to-1 ratio. So this will be sodium hydroxide. Okay, let's keep going a little bit. Oh, here is barium. We have 2 bariums, and this is our polyatomic anion, is our nitrate. So we're going to bring a formula together. So barium, and I need 2 nitrates. And the name is barium nitrate. Okay, let's look here. Wow. So what do we have? We have aluminum. And aluminum is 3 plus charge, and this is our acetate. So that's it's a pretty complicated anion, acetate. So we have our C2H3O2, and that's only 1 minus charge. This is why I need 3 acetates for 1 aluminum. So the name is aluminum acetate. Okay. Oh, I have a Roman numeral as my next example. What's going on here? Remember, Roman numeral is the charge. It tells me the charge of my cation. So it says iron 2. Oh, that means I have iron will be my 2 plus charge. And now I have sulfate. Oh, 8 is the one with more oxygens. Sulfate, formula for sulfate is SO4 2 minus. So now it's going to be a 1-to-1 ratio. So we have iron, and then we have sulfate. So here is iron to sulfate. Okay, next example, we have cobalt, and that's our transition metal. Remember, cobalt can be 2 different oxidation states, so I have to write my Roman numeral. And this is now dichromate. So we will have cobalt, and we need a parenthesis. Okay, remember our trick? We're going to change things. So how many cobalts do we need? We need 2 cobalts. How many dichromates? We need 3 dichromates. So here is this, our cobalt dichromate. So it's our cobalt. And we need to have our Roman numeral in parentheses. And it's dichromate. Okay. And here we just for fun, let's put 2 polyatomic ions together, where the first one is ammonium. What is the charge for ammonium? I mean, the formula, it's NH4 plus 1 charge. And then we have phosphate, PO4 3 minus. So we have ammonium. Ammonium phosphate. So here is some examples how to name ionic compounds. And let's go a little bit more. Let's practice naming molecular compounds. Remember, these are molecular compounds, so we have non-metals only together, and we are going to use the prefix system. Many people ask, why don't we use prefix system for ionic compounds? We do not use a prefix system for ionic compounds because they, by definition, have to be neutral. Remember, it's the smallest whole number ratio of your formula unit, which has to be neutral. This is why it's already understood that you do not have to specify what number you have. But molecules, that's a different story. They are separate entities. So let's go here. So we have 1 nitrogen. So we do not start with mono. So we're just going to start with nitrogen. And then we have 3 iodides. So we have nitrogen. And then we have triiodide. Remember, you drop the ending at the ide. The nitrogen triiodide, it's a very, very explosive chemical. Okay, let's go here. We have 2 phosphorus and we have 5 sulfur. So we're going to use a prefix system. So for 2 is di, So we have diphosphorus. And what is 5? So we have penta. Sulfide. Okay, what about this one? N2O. So we're going to say it's dinitrogen. And now we're going to say monooxide. Dinitrogen monoxide. What's dinitrogen monoxide? It's laughing gas. Okay, let's keep going. We have our sulfur dioxide. Well, there is one sulfur and there is oxide. So oxygen, how many oxygens? 2. Sulfur dioxide. Carbon monoxide. Oh, a very, very bad poisonous gas. So carbon and only one oxygen, monoxide, CO. Okay, diphosphorus pentoxide. This is actually very similar to the example above. So 2 phosphorus, diphosphorus, and pentoxide. Okay, and what about this one? Well, we have silicon, one silicon. We do not say mono, right? So we just say silicon. And then we have chlorine. So we just have chloride. How many? 4. Tetra. Tetra chloride. Whenever I write anything with silicon, I come up with think of a really funny joke. What do you call a clown in jail? Silicon. Thanks for watching. I hope you learned how to name ionic and molecular compounds.